Hi, it's me again, I'm Nafed. So today video will be about Aruba OS 10 and cluster redundancy. That's use case 1. We're going to have 2 use cases. So basically what we have here, we have the access point and we have the 2 mobility gateways. These 2 mobility gateways belong to one cluster. So within that, there will be the tunnel that will be established between Aruba OS 10 access point and the mobility gateway, and there will be another tunnel will be established with the other mobility gateway. And this is basically when you advertise a WLAN that is tunneling, there will be these 2 tunnels, and we're going to verify this. So this is redundancy within the cluster itself, and that means that you are able to have a redundant gateway. Should one gateway go down, the other one will take over. A second use case is basically a multi-cluster deployment. So this mimics the situation whereby you have a client, or yourself or the company or the institute will have two SSIDs. One is tunneling, and that will tunnel to one mobility gateway. The other one is also tunneling, but it will tunnel to a different mobility gateway. And the way to achieve this is to have a multi-cluster. And so basically you have a group where the access point belong to, and you have another group where the gateways belong to. In that group you will manually create and configure 2, in this case, clusters, and you will map each gateway to a cluster. And then you will establish your tunnels or SSIDs. Then you will establish one of them will terminate the tunnel on one gateway, and the other one will terminate the tunnel on the other gateway. Obviously, in the same cluster, you can have redundancy, but in this case, we're only demonstrating the fact that we are just showing you how one AP can have multiple connections, and this can, for example, be employee SSID, and this can be guest SSID, where this mobility gateway can be sitting in a DMZ or DMZ, and the traffic will be completely segregated from each other. Let's go. So as per our setup, we have 2 wireless gateways, and we have one access point that is, we created the SSID or WLAN that is tunneling. Now, if you look at that access point, you have 2 WLANs. One is tunnel and one is bridging. And if you look at the one that is tunneling, we are directing the tunnel to the cluster per the group. So if you look at, if we edit this one, and you look at the VLAN where the client termination, it says primary gateway cluster. This is the gateway cluster, that is where the gateways belong to. And the name of the cluster was picked up as automatic name, because when we added the gateway to the gateway group, we said leave the gateway as cluster mode as automatic, and it is per group, meaning any gateway that is added to that group will be a member of that cluster. Look at the name of the cluster, auto gateway or GW cluster _133_0. If you go to the access point where the client will tunnel the traffic, it will turn the traffic to that cluster. So if you look at this, look at the VLANs, and that is the name of the cluster, basically. This means any controllers added to that cluster will be part of the redundancy. The access point will form 2 tunnels, one towards one gateway, which is the main gateway, and the other one is the backup. So if we look even at the command line of the gateways, show crypto IPsec SA, we can see 2 tunnels, one from the access point to the gateway itself, and one from the second controller to the gateway. And that will be the same case for the other gateway. one from the gateway itself, or the backup gateway, to the other gateway, which is the initial or the original one, and these are the flags. Another one between the access point and itself. So meaning, let us say there's a client, and there's a traffic going on. If we down one controller to mimic redundancy, it means the other controller will take over, and that is also called redundancy. So at this level, the controllers are on the same VLAN, and if you lose one controller, or if you lose one gateway, the other gateway will take over and the traffic will not be interrupted. And we're going to try that in a second. So now this is the client. We're going to connect to the tunnel SSID imp tunnel, and we can look at the IP address for that, and we have picked up an IP address in the VLAN intended to be. We'll verify the failover between one gateway to another gateway. We can see two tunnels, one per each controller. Now we need to verify where the user is located. So we can issue the command show user or show user table. And we can see there's a user here. This is the client that is connected right now. If you look at the backup controller, and issue a command show user, there's nothing. We will mimic a failure. We'll either reboot the other controller or make it unavailable. So we'll make the main gateway unavailable, and we'll see. First of all, we will start ping command from the client, and we'll have a continuous ping command, and then we will fail over to the other mobility gateway. We will fail over the other gateway. We're going to reboot this gateway to mimic a failure. So that gateway is reloading. We'll go back to the client, and the continuous ping command still continuing. You will notice that there is no drop in the packets. And you will also notice that the client session is on the other mobility gateway. So the session continued. We give it a few more seconds. We will go and double check on the standby or the backup mobility gateway. So we see only one tunnel because the other mobility gateway is gone down. The user session transitioned into the other mobility gateway. You can see only one ping timeout, and there is nothing really. If you look at all of that, there's only one ping timeout, which are no issues whatsoever in transitioning to the other gateway. So we demonstrate in this case when you have two mobility gateways in one cluster, and there's a layer 2, and they call seamless roaming, because they both are on the same layer 2 domain, if you like. So as we said before, these two controllers are in one cluster. So the case was basically access point has two tunnels, one to one of the controllers in the cluster, and the other tunnel will be on the other controller in the same cluster. So if you look at what we have on the screen now here, we are on the gateway group. This is the one where the gateways belong to. We click on devices, click on cluster, and you can see there's one cluster here, and it says in here two controllers. Click on the arrow next to this one, expand it. You can see the list of the controllers in the cluster. In the next one, we're going to mimic something different. So use case 2 mimics the situation, say for example, where the customer has got access points and they advertise SSIDs for different purposes. Example, they might advertise SSID for the employees, and in this case, imp tunnel, that might terminate in one controller or one gateway that is in the LAN. The other SSID might be guest, tunneling to another controller that might be in the DMZ. And then the traffic will be completely separated from each other. That's what we're going to mimic in here. So in this case, two gateways belong to one customer. That's okay. The access point is the same access point. The two gateways, each of which will be on different cluster. And then we will see the termination of the tunnels on different clusters. In this case, there's no redundancy within the cluster. But the purpose of this use case is to demonstrate the fact that the same access point can have two different tunnels, one in each, or each one of these tunnels in different cluster. The cluster obviously can have one or multiple gateways, but the purpose here is just to show you that we can form multiple tunnels to different clusters. I'm going to create another group, and that group will create two manual clusters, and then we will map each one of these gateways to each one of these new clusters, right? So we'll go to the groups. We call it MultiCluster gateway group, gateways, leave everything as is. So we're going to go to the group itself. So click on that. That will take you to the group. So we will start the configuration. Click on devices. Remember, we have not yet added any gateway to this group yet. Click on the advanced mode. That will enable you to create your clusters basically. You go to high availability, start creating the clusters. So we have two clusters in that group. Now we need to just look at the gateways. Basically, you need, of course, assume the gateways are reset from factory default. What we need to do is to map the gateways into the group, the gateway group. Remember, we have created a group, and that group we call MultiCluster gateway. I've added them already to the group, as you can clearly see. Now you have multiple ways. If these gateways are just brand new, i.e. factory defaulted, you're going to see them as unprovisioned devices. In this case, we have no unprovisioned devices because I have already added the devices to the group. So to add them to a group, I'll show you to demonstrate that. Click on the device or devices. You can select multiple devices. Click on this, move to the group, and you select the group. We will not do it because we've already done that in this case. Now, once you've done that, you need to go to the group in question, which is this group, and you click on devices. That will take you to the list of devices in that group. Now, one of these devices already been added. I'll show you what I've done onto the other device. So to configure things, you need to go to config mode. And as we have explained before, high availability, that's all sorted out. Now, when you go to the config mode and you are in the group itself, now as best practice, you would like to select each individual mobility gateway. So let's go back to the list, and we've done one of them. Let's select another one to do it. So this one is still booting. Let's click on it. Even if it is down, that doesn't matter. So when they come up, they will pick up all the settings. We have selected one of these mobility controllers or mobility gateways. We click on device. That will take you straight to the config mode on that device. Now that will take you to guided setup. It's up to you, you can come out of it, but I advise just start with this. That makes your life much easier. you begin the guided setup, and the first thing they're going to ask you about the system IP. Remember that system IP is a must-have, and keep in mind the subnet mask is /32. So in this case, we're going to give it a system IP address. Move next. Without system IP, no configuration will be pushed into the device. Let's give it a host name. Let's call it Guest Gateway. We finish. That will take us to another screen, basically. Continuing, that will be LAN. So we've done the system. That will take you to the LAN settings. So continue here. That will take you to LAN settings, and you can clearly see the VLAN ID 4087 has been automatically created. We're okay with that. Now it's up to you. You can go next. At this stage, you have the ports, basically. You can add a port here, which in our case, we're connecting this device on interface G000. It will list all the interfaces here. We leave it as is. The name, we would like to give it just the same name. You can give any name, basically. You can give any name, basically. So we give it the same name. It doesn't matter. I will leave it access. I will not touch anything else. And we go next. We will amend these settings later on. We're going to add VLAN and change the interface to trunk and so on. So click finish here. If everything works and if the zero touch provisioning has worked on the mobility gateway, the mobility gateway will boot up, will reach, activate, will contact Central. We have a license, everything should be working, and the gateway will pick up the native VLAN, which is going to be 4094. Now this is our gateway. Now this is our gateway. You can clearly see has picked up. It managed to get or to successfully perform zero touch provisioning, and in a few minutes it will appear in our list as up. Now that's the group, you can clearly see, and it is up now. Let's click on that controller or that gateway, and let's go to device. That will take you straight to the configuration mode on that specific device. Notice the interface has picked up an IP in 4094. So that is the access VLAN now. That's a default behavior. If that doesn't happen, it means there is an issue. So there we go. Now we would like to change that interface from access to trunk because I would like to allow other VLANs. But before we do this, because this is going to be the one that we can, so this is where you add the VLANs, and if you make a trunk, then the traffic will leave on VLAN, whatever VLAN that you have configured on this one. So let's first of all go to the system and change the name of that host. And it is already changed. If we now double check and we just change the password and make it admin1. Now that password should be pushed to the gateway. And if we go to the gateway, try to log in, that should work. So we have now two gateways that are up, each of which has been configured with the system IP, but each of them should belong to a different cluster. So let's have a look at that now. So we go to high availability in here, and we can see that this cluster employee has one gateway, another cluster guest has another gateway. So that's our gateway, and the other employee has the other gateway, and that gateway is the one that's supposed to be handling the employee traffic, and this gateway should be the one that is supposed to handle the guest traffic. We are mimicking that kind of situation. Let's log in to this gateway. Now you can clearly see the gateway has picked up the password, And if we issue the command show VLAN, for example, you're going to see there are two VLANs being added automatically, 4087 being the system IP VLAN and 4094 being the untagged or the native VLAN as here. We have not yet configured any additional VLAN in this case at all, but we will show you the tunnel between this. Later on, we're going to show you the tunnels between the gateways and the access point when we configure the WLANs on the access point. Let us say we would like to find if there are any tunnels on this gateway or not. So we're going to see show crypto IPsec SA. We expect nothing, and that's correct because there's now no WLAN that is tunneling to this gateway. And if you'd like to issue the command show data path tunnel, there are no tunnels, absolutely, and that is very much expected because now there is no WLAN that is configured on that to use that gateway. And now because this is gateway 10 or version 10, if I issue the command show AP database, it's managed by Aruba Central. There's nothing really that is showing here. If you issue the command show role info, so there's a command here, we should expect this gateway to be managed. So the managed device, it is managed device, and the master IP is the one that is central IP basically. So the kind of controller, if you like, the master controller is the central. Now let's pay attention to the access point itself, and let's create two WLANs. One being for guests and the other one being for employee. And then we're going to see that each one of these WLANs will tunnel to each controller. And we're going to see that the multiple tunnels created between the AP and the different gateways that we have at hand. I'd like to just focus our attention into the ports, trunks, and create VLAN. So we're going to go for the employee gateway. We'll demonstrate on one of them. And we go to device. And in the device, we'd like to go to interfaces or interface. And we go for VLAN. So we will change this one. Let's just create the VLAN. And I would like to create a new VLAN that will be 1001. And I would like to call this one imp VLAN. Imp VLAN, and I would like to call it the ID, and that has already been configured. It means the traffic from the employee will be tagged on that VLAN. So that's done. We're going to go back to ports, and because we would like that to use that interface, we're going to change the port type into trunk. We have a trusted. It means we don't need to have a policy. So there's no need for a policy. The native VLAN should be listed 4094. I would like to allow VLAN 1001 and 4094, and that's it. This 84087 is a system VLAN that doesn't need to cross the link. Think of this one like a loopback interface, and it says in, it's always up. And it is done for manageability of that specific gateway. And we go save settings. So this gateway is ready to be configured with the employee SSID, and the traffic will leave on VLAN 1001. Let's configure the other gateway because this will terminate all the guest WLANs. And again, I'm just mimicking, or I'm showing you set up a certain use case to demonstrate the use case for multiple clusters. So here again, we're going to add a new VLAN that is guest VLAN. So come here, click on the plus. I will call it guest VLAN. And the guest VLAN, I would like to make it 11. So, and this VLAN obviously has scope on the server. It has the IP helper address and the core switch, all of that being sorted before then. Go to the interfaces or ports. You would like to change this one from access to trunk. Typically, guest will not do this. Typically, guest, the gateway will act as a DHCP server, and then we'll do netting. But again, this is just to demonstrate the multi-use or the usage of multi-controller, multi-cluster situation. Go to trunk, and we go native VLAN again 4094. I would like to allow two VLANs, 11, which is the guest VLAN, and 4094 which is the native VLAN. And clearly see native VLAN 4094. Now we are ready to go ahead to configure the WLAN. So to do this, we will go to the access point group, AP10. We created one before. This is where the access point belongs to, and we're gonna go config. Let's create another WLANs. We can edit this one, but probably it might be a good idea to just delete this. And this was a bridge mode WLAN. We're going to delete that one, the other one as well. Let's create a new one. Click on the plus to add a new WLAN. Let's call this one imp for simplicity, imp WLAN. And we go next. Here we select the mode of traffic forwarding, and we're going to say tunnel, and we're going to select our cluster. This is the employee, so we're going to select this cluster, and we're going to static VLAN again, just for simplicity, and we're going to see the list of VLANs. I would like to go for VLAN 1001. Go next. We leave everything else as is. We will do personal for simplicity WPA2. Then we go we leave this as is, no problem, not best practice, and we click finish. So the guest WLAN, the employee WLAN is ready to use. Let's go finish, and that is now ready to use. We're going to create another one. We're going to create a guest WLAN. Now again, if you would like to go create proper guest WLAN, you would have gone to guest and create splash pages, but I'm going to use the default. There are some splash pages have been created before, but we will not show. This is not the focus of this specific video. So let's go back to devices, and we go config. Again, we are in the WLAN page. Click SSID, add SSID. I would like to call it guest WLAN. Next, tunnel, and we're going to select the cluster, that is the other one, and the VLAN we would like to go for is VLAN, different VLAN. We're going to go for VLAN 11. We're going to select the multi-controller gateway group guest, and the VLAN that will be available will be VLAN 11. Next, again, let us say now we're going to use simple visitor stuff, and we're going to use cloud-based guest. Again, we can go to default, leave as is, or you can go to something different, guest self-registration. These are things that have been created before. So again, I'll go to self-register. For the key management, we make it open to avoid any issues, compatibility between Windows 10 and the system. We go next now, and everything is ready for us. We go next, and then we finish. I'm going to create WLAN employee, so we're going to give it a name employee WLAN. Next, we're going to go tunnel, select the cluster that we have. We have this cluster, basically the one belongs to the group. So we're going to go employee, and VLAN static. We're going to go for Again, remember, we have these two WLANs. One is captive portal, one is the pre-shared key. And if you click on any of them, you can look at the details of that. Just to reconfirm, we went to the mobility gateway cluster or group. We have created 2 clusters, and one each cluster that's in high availability, and we mapped each one or individual gateway to a cluster. And then what we've done here, at the high level or at the group level, we created the VLANs. So VLAN for the guest, VLAN for the employee. These are 2 different VLANs, where the guest traffic will terminate on, where the employee traffic will terminate on. So we've done this at the group level. We haven't touched the ports. We could have done it if we wanted to, but we wanted, because these 2 gateways, each one of them will have a trunk port will egressing different VLANs. I chose to go for the gateway level. So we go to the list, and if you click on the employee gateway, you're going to see, and you go to device, you're going to see that the VLANs that we have created are available here, and we created this trunk port. You can clearly see that we have defined these as permitted VLAN or allowed VLANs. We could have, of course, 11 is available as well, and the native VLAN is 4094. That will be similar story to the other gateway, which is basically gonna egressing VLAN 11 and VLAN 4094. So there we go. This is the guest WLAN, guest gateway. Go to device. That's the interface G00. That is the one connected, and where this is the one where zero touch provisioning has taken place on. Again, trunk 4094, the VLANs 11 and 4094 are permitted, nothing else after that. So now it's time to look at the tunnels that exist on the access point, as well as on the tunnels that exist on the mobility gateways. So for the access point, we can SSH, but let's use Central to get to the access point. So let's go here. We're going to discard. Look at the controller. Issue the command show data path tunnel. We're going to see, we should see a tunnel between the access point and the controller. So that's a tunnel, you know, the SPI in from the control to the access point and out. We're going to see something similar to the other gateway as well. So connect to this gateway and show data path tunnel. We should see something similar to that as well. Now there's no client, but these 2 SSIDs or 2 WLANs should have created 2 tunnels. So again, this is a tunnel between the controller or the gateway and the access point, GRE tunnel. And this is the SPI, which is basically for the security tunnel. This is the related to the WLAN that has been created. We're going to connect a user to one of these, right? Try to connect one of the users to WLAN employee. So it's going to ask for username for pre-shared key. Seems to be working. So if we go to the mobility gateway and find out, and if we issue the command show user here, we issue this command show user, we can clearly see there's a user, the role for this one, and that's the MAC address of the user, obviously, and connected to this SSID, to this access point. And if we look at the show data path tunnel, same. So we can issue the command show data path use session also. we can see now there's a client connected and there are sessions, so that these are things that are happening on the client and so on, as well as all other sessions as well, right? If we use a different client to connect to the other SSID, now we should see that there's a user on the access point. So if we issue the command show client on the access point, we're going to see one client added, right? That's the access point, and there's this show clients command on the access point. We're going to see a client has been seen, and it is channel 6. GN means .11n 2.4 frequency. Let's connect to the other guest client. We can see another user showing up on the other gateway, and we're going to see a list of 2 clients here. So here we connect to the guest. Again, this is just to demonstrate the fact that we have 2 users and we can see them. Now should redirect us to a capture portal. Very simple one. So I can register. I don't have, I can register. I would like to register with the phone. So go with the phone number. And probably sign in. I accept the terms and condition. That's a different one. So this is register, and I would like to accept the terms and condition. Phone number 0787. That's my phone. 5965285. Accept terms and conditions. There we go. So now we are connected. Hopefully that should work. And once that's the case, we're going to go to the other controller here. And we're going to issue the command show user. Should be another user. This is Guest WLAN. If you go to the access point itself, you're going to say the same command show clients should see 2 clients. Now we can see the 2 clients, and each one of them on different gateway. At the end of this video, I'd like to thank you very much for watching this video. Don't forget to subscribe to my channel, and I'll see you in future videos. Thank you very much.